So we're going to take a look at equivalent fractions. Let's say we have 1. Okay, if this whole, let's say it's a pizza, if this pizza is not cut into any parts and you eat it all, you would eat 1 out of 1 of the whole because there's only one piece. It's a big piece. Alright? The next thing, if we want to make it equivalent to something, let's say you're going to share this pizza. Let's say you're going to be sharing it with 4 people, you and maybe 3 friends. Okay? So now we have 4 pieces. 4 pieces. Okay, if you eat the whole pizza yourself, then you would have eaten 4 out of 4 pieces of the pizza. Okay, so 1 out of 1 still is equal to 4 out of 4. Alright, now let's say you're having a little party. So not only are you going to have 3 friends, but maybe there are 8 of you all together. Okay, so we're going to split this pizza up into 8 pieces. And let's say we want everyone to have 1 piece, and you guys are going to eat up all the pizza. If you eat up all the pizza, you've actually eaten 8 out of 8 pieces. Alright, so 1 out of 1 is equal to 4 out of 4, which is equal to 8 out of 8. Alright, now let's look at it also this way. Let's say that you didn't eat 4 out of 4 pieces of the pizza. Let's just look at the piece that you ate. Okay, let's just look at the piece that you ate. Let's say you ate 1/4 of the pizza. 1 out of 4 of the pizza. Okay, so you had 4 friends, you ate 1 out of 4 of the pizza. Let's say in this case here, let's say you still just had 4 friends eating this whole pizza. Okay, and so you still got to eat the same amount. In this case, you still ate 1 out of 4 pieces, but it looks like 2 out of 8 pieces. Okay, because the pizza was actually cut into more slices. So you ate, instead of 1 out of 4, you ate 2 out of 8. But those are equal. Okay, we could take this one step further. And let's say that this pizza is actually split up, not into 8 pieces, right? Not into 4 pieces, not into 8 equal pieces, but let's say we split it up into 16 pieces. Alright, 16 pieces of pizza. Now, you see the pizza didn't get any bigger. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Good, I got them all there. They're not quite the same size, but they should be for this kind of experiment. Alright, and so instead of eating 1 out of 4 pieces, or 2 out of 8 pieces, you're going to eat 4, 1, 2, 3, 4. You're going to eat 4 out of 16 pieces. 4 out of 16 pieces. So you see how these numbers on the bottom and also on the top, both the numerators, which are the top numbers, and the denominators are getting bigger. However, the actual size of the pieces of the pizza, or the portion of the pizza that you're eating, the actual portion of the pizza that you're eating is staying the same. The only thing that's changing is how big or small the pieces that you are eating are. If you eat 1 out of 4 pieces, you've eaten a pretty big piece. Alright? But if you start to eat 2 out of 8 pieces, well, the pieces that you ate got smaller, but you still ate the same amount of them. Okay? If you eat 4 out of 16 pieces, that means that pizza was cut into tiny, tiny pieces for you. Alright? And instead of eating 2 of them or 1 of them, you ate 4 of them. Alright? So this is just kind of an explanation about how equivalent fractions work and why some fractions can be actually equivalent to each other. The numbers can change and get bigger, but the actual part that they represent in an object stays the same size. Alright? So that's just a little bit more about equivalent fractions.